NASA and ESA's solar orbiter begins its nearly 2-year journey to the Sun. After years of development, an exciting new scientific research spacecraft has launched on its journey to study our solar system's central player, the Sun. The solar orbiter, developed jointly by NASA and the European Space Agency, ESA, and built by Airbus, lifted off from Cape Canaveral Air Force Station in Florida on Sunday night, launching as planned at 11:03 PM EST, 8:03 PM PST. Solar Orbiter launched atop her United Launch Alliance (ULA) Atlas V rocket, featuring a unique configuration of the launch vehicle designed specifically to get the nearly 4,000-pound observation craft off Earth and onto its target path to eventually approach the Sun. The Atlas V used for this launch was configured with a payload fairing 13 feet in diameter to accommodate the orbiter, and used a single solid rocket motor to provide the necessary propulsive power. From here, Solar Orbiter embarks on a journey that will take just over a year and a half, and include 2 close passes to Venus and Earth in order to take advantage of their gravitational pull to propel the spacecraft toward its target destination while conserving as much fuel as possible. After it swings by those 2 bodies to gain momentum, it'll end up in an orbit around the Sun with a close approach distance of just 26 million miles, still about 100 times as far as the Moon is from Earth, but so close that temperatures at their peak at the spacecraft will reach nearly 1,000 degrees Fahrenheit. Solar Orbiter's mission sees it orbiting the Sun for at least 7 years, gathering data about what's going on in the star's heliosphere, which is roughly equivalent to Earth's atmosphere in that it surrounds the Sun. These findings should shed new light on what goes on in the heliosphere, which will definitely be advantageous for scientific study of our solar companion, but they could also provide new information that leads to better understanding of so-called space weather, which includes things like solar storms and flares that actually impact the proper functioning of infrastructure, including communications and navigation technology back on Earth. On board Solar Orbiter, there are 10 instruments to measure various phenomena and gather different types of information from the Sun, including permeating ultraviolet imaging and taking measurements from the solar wind that radiates off the star. All of these instruments had to be hardened to withstand not only those extremely high temperatures from the orbiter's closest approach to the Sun, but also down to nearly -300 degrees Fahrenheit, which is an amazing engineering challenge when you're dealing with instrumentation designed to detect very fine detail. They'll be protected in part by a heat shield made of titanium and covered with a calcium phosphate coating. For more on this story, visit the news article link.